In this video, I introduce neural Turing machines. Neural Turing machines couple external memory sources into neural networks to extend the capabilities of neural networks through attention mechanism. The NTM architecture contains two basic components, namely a neural network and controller and a memory bank, as shown here. This controller, this is a memory bank. In addition to interaction with the external world via input and output vectors, NTMs interact with the memory matrix using selective read and write operations as shown here. The blurry read and write operations interact to a greater or lesser degree with all the elements in the memory, which are determined by attentional focus mechanisms. The memory location brought into attentional focus is determined by specialized outputs emitted by the right head. Our head can attend sharply to the memory at a single location or weakly to the memory at many locations. NTMs use the current neural state and information read from the memory matrix to compute the output. The intended location in memory matrix is determined by specialized outputs that define normalize the weighting over the rows in the memory matrix. Each weighting, one per read or write head, defines the degree to which the head reads or writes at each location. Suppose that MT is the content of N by M matrix at time t, as shown here, where N is the number of memory locations and M is the vector size at each location. WT is a vector of weightings over N locations emitted by a read head at time t. The normalized N element WT of WT satisfy the summation equal 1. The length M read vector RT retained by the head is defined as sum of WT by MT as shown here. Where MT is the raw vectors in memory and RT is differentiable with respect to the memory and the weighting. The weighting WT is emitted by a right head at time t, along with erase vector ET in the range from 0 to 1 generated by the controller. The memory vectors are modified as here and explained in this figure, where MT minus 1 is a memory vector at a time t minus 1, and vector 1 is a row vector of all ones. The elements of memory location are reset to 0 only if both the weighting WT at a location and the erase element of ET are 1. If either the weighting or the erase is 0, the memory is left unchanged. Each right head produces a length n at vector AT, which is added to the memory after the erase step has been performed, as shown here and in this figure. The combined erase and add operations of all right heads produce the final content of the memory at the time t. Since both erase and add are differentiable, the composite write operation is differentiable too. There are two addressing mechanisms to produce weightings WT, namely content-based addressing and location-based addressing. For content-based addressing, each head first produces a length M key vector KT that is compared to each vector MT by a similarity measure key, for example, cosine similarity. The normalized weighting WT is defined as here and shown in in the figure, where beta T is a positive T strings. A feed-forward network or recurrent neural network can be selected as a controller. For more details, please check with these references. Thank you. Bye.